that graph is not on Zoom Trig, it's in numeric radians. So it might help you to read through your window. Okay, so I'm just resetting my window to count like theirs is counting. It looks to me like it's counting by regular, there's no pi's involved here, it's all numeric radians. So I just went from -4 to 12, counting by ones on my x-axis. And it's actually, it's counting by halves on your y-axis. Okay, and the only reason I did that is because on the page, they're calling this first point over here x1. This is x2, x3, x4, and x5. So that way I can find those. So I'm going to do an intersect, a second trace, and find the intersection. All the way over here, find x1. Okay, so that first value that I got over here is, I know you can't see it because of the glare, but it's -2.094. Now that is if this was Monty the cat, that's Monty coming out of the water. X2 over here is going to give me Monty going into the water. So I'm going to find that one.
Because look, he goes up and down. Of the half. Negative.
Okay, so this is x2, and it's positive 2.094. Now I don't actually have to find any more points because I can just add, what am I adding to this?
2.
4.
4.
What's your period?
4. No? There's the top.
What's the period of cosine?
Pi.
Start.
2 pi.
2 pi. The period of cosine is 2 pi. Look at that equation. Has anything happened to it? Has it been stretched, shrunk, anything?
No.
So what's the period?
2 pi.
2 pi. So I'm going to find my next 2 points. I'm going to add 2 pi. So this is coming out of the water point, -2.094. If I want this coming out of the water point, I'm going to add 2 pi to it. So, so in my calculator I actually put -2.04 plus 2 pi, and I get 4.189. My positive point, and if you look at it on the graph, you can see it is just almost at 4, so it's a little past 4. My next point, this one was positive 2.094. Add 2 pi. 8.377. That's this one. This is coming out of the water point. So I had this one. I can either go back to x3 and add 2.04, or I can go all the way back to x1, which was this one. Since it's in my calculator, I'm going to go ahead and do that. -2.094, that was it coming out of the water point, plus 2 pi times 2. Does everybody understand why I'm doing times 2?
This is the second one. This is the second one.
Right, because here's the first one coming out of the water point. Here would be the second one, that would be just 2 pi, or the first one following the one I found. And then this is the next one. So this would be plus 2 pi, this would be plus 2 pi again.
And if it was
Or
again, it
2
would
pi.
be 3.
3. We would do 2 pi times 3, and then
Why
we could
can't-
do 2 pi times 4.
Why can't you just do x3 plus 2 pi?
You could, but there's a reason why I'm saying that. So, It'll all make sense in a minute, but you absolutely,
Like I don't have to do times 2.
no, you could
Okay.
do, you would have to use the x3 point and add 2 pi to it, yeah.
Okay.
Later it's gonna ask us for like a basic
So I got
Yeah, probably.
10.472 for my x5 value. Okay, so we have now found x1, 2, 3, 4, and 5. So we just solved that equation. That's just exactly how you solved last night, right? Everybody's okay?
Yeah.
So now, it says underneath that, a second method is to solve it algebraically and use inverse cosine. So, remember, solving something since the beginning of solving, which was probably 6th grade, you are trying to get x by itself. So right here, the word cosine is with x, and I need to get rid of the word cosine. In order to get rid of the word cosine,
You have to move it.
you inverse cosine, or you arc cosine. Just like getting rid of addition, what do you do to get rid of addition? Subtract. To get rid of multiplication, you divide. To get rid of cosine, you arc cosine, or you inverse cosine. So, if I inverse cosine, not sine, if I inverse cosine this side, I have to inverse cosine this side. Over here, that cancels the word cosine and leaves x by itself. Over here, I have inverse cosine of -1/2. Everybody okay so far? We've done this before.
Yes.
Alright, so now
Yeah.
we're taking everything that we've done and we're starting to put it all together. So now we are inverse cosining without your calculator.
No?
Oh,
So, for what?
Yeah, Caleb.
So they're going to take you through the steps of how you do it. So the first thing you ask yourself when you're trying to arc cosine is, what reference angle is cosine equal to 1/2? Alright, left hand trick.
5/3.
Hold on a second, because
All right.
yes, I know you can look at the table at the top. Left hand trick. Which set of fingers represent cosine? My top fingers or my bottom fingers?
Top.
I need my top finger to have a 1 on
Right here.
top. Which, that would be one finger. So then that means this needs to be folded in, yes? When I just folded that finger in, what angle does that finger represent?
5/3.
Pi over 3. So we just figured out what reference angle equals 1/2, pi over 3, which is 60. But we're in radians right now. But it is, if you were doing degrees, it would be 60. Alright, so now I have to figure out in what quadrants cosine is negative.
2 and 3.
That's because it's -1/2. So where is cosine negative?
2 and 3.
Quadrant 2 and 3.
That's the only stuff I put pi instead of 2.
So pi over 3, is it in quadrant 2 or 3? Pi over 3? No, what quadrant is it in? Okay, so pi over 3 is just my reference angle. I need the angle that's in quadrant 2 that has a 3 on bottom. What would that be? 2 pi over 3. If you're not sure how to get that, if you'll remember that this is 0 and 1. This is pi, which means it's also 3 pi over 3. And 4 pi over 4, and 6 pi over 6. But it's 3 pi over 3, which means if I need to back up one, that has to be 2 pi over 3, yes? Okay, so I also need quadrant 3. Well, if this is 3 pi over 3, I need to go down 1.
4 pi over
4 pi over 3. Okay, so it's asking now on D, which graphical solutions, x1, x2, x3, match these values? So real quick, let's put it in our calculator. I'm going to put 2 pi divided by 3. And it gives me 2.094.
Wow.
Which one is that?
X2.
X2. What about 4 pi over 3? Which one is it?
Ooh.
X3. I think it's 3. Is it 3?
It's x3. Which is good, because I have it going under the water answer and it coming back out of the water answer. So x2 and x3 are what these two represent. Now, let's talk about how we can find x4 and x5. We'll talk about x1 in just a minute. But how could we find x4
Go to the next,
6
go
pi
to
over
5 pi over 3.
But,
So,
no, you're not wrong. But easier, explain to me, how do I get from what I know, say, this going under the water answer, to this next going under the water answer?
Add 2 pi.
Add 2 pi. So I could take 2 pi over 3 and add 2 pi to it. Wouldn't that give me the next going in the water answer?
Hey, yeah.
What would give me the next coming out of the water answer? So my x5 answer.
Add
6 pi. I need it coming out of the water answer. These are both going in the water answers.
so it would be 4
4
pi.
pi.
4 pi over 3 plus 2 pi. Because that's the coming out of the water answer. Okay, well what about this? I need to back up to x1.
Minus.
Minus 2 pi. Which one am I going to subtract from though?
4 pi.
4 pi over 3 because it's a coming out of the water answer. So to get x1, it would be 4 pi over 3 minus 2 pi.
Can you say that again?
Yes, please.
Sure. To get x1, I'm backing up. That's a coming out of the water answer. So I can use this answer, which I already found, 4 pi over 3, and subtract 2 pi.
Because it has to be the same
It
thing.
has to be the same type of point, a coming out of the water answer, not a going in. Okay, now there's still more questions about this on the top of the next page. How can we generalize this to represent infinitely possible solutions? So we found x4 and x5, but what about x6 and x7 and 8 and 9 and 10
Hey,
and 11?
you take your first x and you add 2 pi.
You take your first x and you add 2 pi, and you add 2 pi, and you add 2 pi. So if we're going to generalize that, I would say x equals 2 pi over 3 plus 2 pi, how many times?
In.
N times.
Look at there.
And x equals 4 pi over 3 plus 2 pi n times. And that's because I need both the going in the water and the coming out of the water answer. Why can my solution also be written this way? As positive or negative 2 pi over 3 plus 2
Because you
pi.
can go backwards.
Because you can go backwards. You can go around the unit circle backwards. You can back up on the x-axis. This right here, n is an element of the set of j. It means integers, just like we talked about yesterday. Whole trips around 1, 2, 3, or -1, -2.
Wow.
All right. So moving on, we're going to solve another one.
Hey.
Remember, the whole goal here is to get x by itself. So what should I do first?
Hey.
Divide by
2.
2. And then we do need to get rid of sign, so we will inverse or arc sign. And if we arc sign the left, we have to arc sign the right.
Hey, Jeff, how about this?
Okay, so now right here is once we're actually having to take the arc sign, that's when we go to our hand, or I realize you have a table on the front of your page. I'm not going to give you a table on the test. Now, if you want to recreate that table at the beginning of your test, just kind of write it at the top of your test, it might save you some time. So you could always do that, but for right now we're just going to go through and use our left hand
I have
trick.
a phone.
We need to figure out, we did that, what reference angle sine equals square root of 2 over 2. Now when we're using the left hand trick, top fingers or bottom fingers?
It doesn't matter. It's
Uh-huh,
gonna be
well.
two on either side.
For sine though, just tell me for sine, top fingers or bottom fingers?
Bottom.
Bottom finger. So I need 2 fingers on bottom because there's a 2 in the numerator. So 1, 2, which means I need to fold this finger in. What angle is that?
45.
45, which is
Pi over 4.
pi over 4.
Why is it cosine the top of it?
Because cosine is x and
Okay,
sine
okay.
is y. And so it's alphabetical order. It's all alphabetical order. C comes before S, X comes before Y, top comes before bottom. Okay, so now I need sign to be positive. Where's sign positive? 1 and 2.
C becomes.
Is pi over 4 in quadrant 1 or 2? It is. So that's my first answer. That was good. So pi over 4. And I need whatever has a 4 on bottom that's in quadrant 2. So this would be 4 pi over 4. 3 pi over 4. Okay, now we need to figure out how we would find more. So this is a going down and a coming up answer. I need the rest of them. The ones that come after, or the ones that come before. How do I find those? Add what? 2 pi, because 2 pi is the period. So x equals pi over 4 plus 2 pi. I put plus or minus, because that could go the other way.
Very true.
How can we generalize it? We generalize it by adding that in. You're really multiplying it, but.
Oh, yeah.
Okay, so next question, it's kind of a strange question. Question G. How are the two solutions that you found related by pi? What they really want to know is how far apart are they?
2 pi.
2 pi.
Oh,
No, it is.
yes, but they wanted to know how far apart are these two.
Oh,
Oh.
they're not.
Wait,
far.
And why are they not 2 pi apart? That's a good question. How far apart are these two answers?
They're
Oh, hey.
a half apart.
They're a half a pi.
Pi over two.
Half pi apart.
Oh, no.
Yes.
Why?
Because
Oh, because pi is 2's in the middle.
if you got quarter and you had 2 quarters, and you get 3 quarters. 3 pi.
Sure. Yeah, I'll send him.
Invoice.
Alex, Miss Cordell needs
Because
to
5 over 4 is 4.
I need you to explain something. Okay, they're a half pi apart. So I thought that the solutions were always 2 pi apart because of the period. Why are these two only half a pi apart?
Because that's how math is.
Yeah, pretty much.
Hey,
Duh.
It's not what?
Not from my peak to peak, it's from,
It's not from peak to peak.
It's from the line. Is it
What
from
is
line
this
to line?
answer?
that's the.
So in the water now.
Going in and coming out of the water. So they're not 2 pi apart. But a going in answer is 2 pi from another going in answer.
Wait.
And another going in answer.
But a going in
These
and
two
coming out is just half.
is a half
apart.
pi. A half pi apart.
How would we
So
write
in
that?
who is it?
How would we?
So how am I supposed to write that?
Yeah.
If it's 2 pi apart, wouldn't it?
All they asked you was how far apart are they?
Okay.
Do what? How do you get from a quarter to 3? How do you get from a quarter to 3 quarters?
You add 2 quarters.
That's it. They're 2 quarters apart, which is a half.
Hey, so 2 quarters would
2
be.
quarters is half a dollar.
Yes. Okay.
So they're half a pi.
So we
I
put,
don't know what
we
I'm
put
thinking.
pi over 2 or 1 half?
You're thinking
Pi over 2.
No, I'm not even thinking 8 quarters of 2.
I was outside.
Okay, so you try the next one.
So 8 quarters would be 4 pi or 2 pi?
What did she say the? Okay, it's negative. It's going this way.
No, it's not pi over 2. It's half of it.
Yeah.
You put pi over 2.
So for tan,
It's just this one.
No
would
pi.
it be y? Y
Shut
over
up.
Y
x?
over
x.
So we have
That's what I'm saying. Right, wait. Hold on, let me make sure it's right.
Yeah, you are.
Yeah.
So would it be pi over 3 or pi?
How do you put pi over 3?
What's that one again?
Cancel.
Hey, I got this.
basketball game?
Yeah.
Over there by the walkway?
Give you a ticket.
The one that
No,
won,
you
he
didn't.
awarded. Yeah.
Tangent is only higher people.
I just don't know how.
Wait,
This is pi over.
would it be
Can you use
negative?
pi over 3?
That's the
Can you use a hand
answer?
trick for that? No.
Yes and no. I know that it has to have a square root of 3 in it, so that automatically eliminates pi over 2, or
Four.
pi over 4, or half pi. So it's gonna have to be pi over 3 and pi over 6. So remember, tangent is y over x, so you have to remember your keep switch flipping. If square root of 3 is over 3, that means you had to rationalize. So
So it had. I don't know.
So you had to keep switch flip, and the square root of 3 had to end up on 5. So it ends up being
that
pi over 6.
tangent power 3 is just regular square root.
That's good. What'd you say?
Tangent of pi over 3 is regular just square root.
Tangent of pi over 3 is regular square root of 3. If you can remember that, then you'll know pi over 6 has to be the other.
1 3 goes 1 3.
This one is pi over 6. So I'm arctangenting.
If you have tangent of pi over 6.
I don't understand why it wants positive.
It's not positive, it's negative.
I know, but like on B, it's.
Okay, because you always have to find the reference angle first.
Okay.
So when you get to B, you're just figuring out the reference angle. That is not a solution.
English, alright.
Hey y'all. When you get to B, it's asking for the reference angle. In this case, we just figured out it's pi over 6. Well, what quadrants is tangent negative?
2 and 4.
2 and 4. Is pi over 6 in quadrant 2 or 4?
No.
So pi over 6 is not one of your solutions. It's just to help you find your solutions. So I need the ones that have a 6 on bottom that are in quadrant 2 and quadrant 4. So what would be
5 pi
what
over 6.
G is asking? What D is asking? It's what?
5 pi over 6.
5 pi over 6.
And 11 pi over 6. No, that's not right.
That's right.
Okay.
If you're not sure how we got 11 pi over 6, we know we need to be in quadrant 4. This is 12 pi over 6 because it's 2 pi. So if we go down 1 and you get 11 pi over 6. Okay, so I need other solutions. How am I going to find the next set of solutions with this? Add pi. Why am I just adding pi?
Because your tan is the period's only pi.
Period's only pi.
I think.
I'm going to say add and subtract. Because that we could go the other direction also and get the negative answers. So how could we generalize that? We could do 5 pi over 6 plus pi n, or 11 pi over 6 plus pi.
That could be plus 1.
Okay, now, do both solutions need to be used in order to represent the infinite solutions? Why not?
I don't know.
Think about tangent and what it looks like.
Tangent doesn't
It
go.
goes up.
Is that this one?
Tangent doesn't go down and up. Tangent goes down and down again and down again. Remember, it has asymptotes and it just goes down. And so it doesn't have a going down and a coming back up answer. And if you look, if I have 5 pi over 6 and I add pi to that, that would be 5 pi over 6 plus, I'm just going to write that as 6 pi over 6. Everybody agrees that's still pi, right?
Yeah.
6 is cancel. Which gives you actually
17.
11 pi over 6.
38.
So this is really the only answer you need for pi. And that's because it doesn't have a going down and a coming back up answer. Tangent only has one intersection per period.
You said it really fast.
Okay, so next thing is this crazy chart. Now, this is now going back to something that we've already learned, but now we're putting this stuff all together. Remember when we first started arc signing and arc cosigning and everything, and we realized our calculator would give us one answer. But your calculator won't give you all the answers when you arc sine or arc cosine or arc tangent. We had to figure out how to get the other answers. You remember, I kept telling y'all cosine's the easy one, because the calculator's going to give you one answer, and what could you do to that one answer? Make it negative. Cosine was the easy one, you just made it negative. And then you'd add 360, add 360, add 360, or add 2 pi, add a trip around the unit circle. Okay, that's what this chart is explaining. So the rules that we learned before, they're back. They didn't ever go anywhere, we just stopped using them for a little bit. But now we're going to explain how it works in regards to this stuff. So all this is saying is if we have an equation like cosine of x equals k, you take arc cosine, and they're going to call the answer that you get, that first answer that would come out of your calculator, or now the first one we get off the unit circle, they're going to call that S. That's your solution. Then, if you need the next solution, which for cosine and sine and tangent, you're going to need the next solution because it's periodic and it happens over and over and over again. This is how you find it. You can make the solution negative and then add 2 pi and add 2 pi and add 2 pi, or subtract 2 pi, subtract 2 pi. It's the same rule. Okay, sine is the difficult one. You got your first answer, got sine of x, we solve it, take arc sine, and we get our solution. You've got a primary solution. Does anybody remember how you get your second solution for sine?
Nope.
It's 180 minus the answer your calculator gave you. It's 180 minus the solution. Or in this case, it's pi minus the solution. The pi comes first. So it's pi minus the solution. So right here you can see, here's the first answer, solution plus 2 pi, because you take the first answer. Here's your second answer, pi minus the solution plus 2 pi in. That's how you get your second answer. One of these is you're going down in the water answer, and the other one is you're coming back out of the water answer. So that's how you get them both with just one solution. Okay, then tangent. Cosine's easiest, then tangent, then sine. Tangent's a little easy too. You just arc tangent it, and then tangent, because its period is not 2 pi, you just add or subtract 180, or you add or subtract pi, which is what this is telling you. Okay, so now we're going to do it. Here we go. 2 cosine x equals negative square root of 3. So what do I do first? Divide by 2. Okay, we're going to arc cosine to get rid of the word cosine. Alright, and now right here is where I have to revert to the left-hand trick, but right now I am only concerned about the first answer I can find, because my little chart's going to help me find the second one. Okay, so cosine, that's the x value, so I need 3 fingers on top, 1, 2, 3, 4 in this. Pi over 6. But pi over 6 isn't negative, because it's in quadrant 1. Where is cosine negative?
4.
Is that the only
No,
one?
2 and 3.
2 and 3, and I only need the one that's in 2, because I'm going to use my little chart to find the other answer. So what has
5 powers.
5 pi over 6? So my solution that I have found is x equals 5 pi over 6. And I will generalize that in just a minute, but before I do that, it says, my solution up at the top says, not only can I use that, but I can also make cosine negative.
So you
That will get my other answer for me. So to generalize this, I'm going to do both positive and negative, 5 pi over 6 plus 2 pi n. And that's all you need, because all this said was write the general solution. And that is the general solution. Is everybody okay?
Yeah.
So doing that will get you both going down and coming back up with answers.
So is that why?
Okay, so the next one, I'm just going to jump straight to arc tangenting. Where is tangent 1? Pi over 4. is y over x square root of 2 over 2 over square root of 2. It's pi over 4. Okay, so that's in quadrant 1. Is tangent positive in quadrant 1?
Yes.
Yeah, everything's positive in quadrant 1. So that can be my first answer. And with tangent, all you need is one answer. Plus or minus
Pi.
pi. Pi n. Because remember, the period for tangent is only pi.
Wait.
So is it plus or is it just plus?
Plus or minus pi n. Actually, I could just do plus, I guess, because my n can be negative, sorry.
So it's more positive solution.
Okay, next. I divided by -1. Now I'm going to arc tangent. Okay, so we already just said, where is tangent square root of 3? Pi over 3. It's square root of 3 at pi over 3. Okay, so is tangent negative in quadrant 1? Because pi over 3 is in quadrant 1.
No.
Where is tangent negative?
2 and 4.
It's negative in 2 and 4. So let's use 2, because that's the first one we encounter. So what has a 3 on bottom in
2 pi.
quadrant 2? 2 pi over 3. So that's going to be my first solution, 2 pi over 3. That's all you need is your first solution. Because my little chart says I can generalize that by adding pi n. Everybody okay? Try D.
Oh man, that's probably a hard one.
It's not. Okay, what first?
Negative.
Good. So I have sine x equals -1/2. Gotta get rid of the word sine. Okay, so I'm looking for a 1 for my sine. Top fingers or bottom fingers?
Top.
Bottom. Sine is y. So you need your bottom, the bottom of your hand to have 1 finger, which means I'm folding in this one, which is what? Pi over 6. Now, everything is positive in quadrant 1. So I need -1/2. Where is sine negative? 3 and 4. So I just need the first one. So I need the pi over 6 that's in quadrant 3. 7 pi over 6. Okay, now, my other answer, so let's say that's a going down answer. I need my coming back out of the water answer. We find that from pi minus the answer that it gave you. So, pi minus 7 pi over 6. Okay, I'm going to write that as 6 pi over 6 minus 7 pi over 6. Is everybody okay? That pi is the same thing as 6 pi over 6? I did that just so I would have a common denominator. If I do 6 pi minus 7 pi, what do you get? Negative pi over 6. So these are the two answers that you need to generalize. So x equals 7 pi over 6 plus 2 pi n, because the period is 2 pi, and x equals negative pi over 6 plus 2 pi n. Is everybody okay? Okay, so for sine and cosine, cosine, you have to come up with two generalized solutions. So why, when we did the cosine one, did it look like we just had one?
Cause you can just.
You make it negative.
Because you can make it positive and negative in the front. So cosine's the easy one. Well, tangent's pretty easy too, but. All right, go ahead and do E, because it's cosine. That one's easy. Cosine is next.
This announcement is from Mr. Bivens, mandatory UIL spelling and vocabulary meeting during tutorials. Also, FFA members, go to the library for pictures. Thank you.
Yes, sir.
Oh, I'm just confused, like, okay, I get to the step where it's like x equals inverse cosine parentheses square root of 2 over 2,
Uh-huh.
but then like, I don't know how to like get to the next step, like the x equals.
Okay, so that's where we are going to our hand for our left hand trick. And so the first thing is you've got to remember that cosine is x and sine is y. So if cosine is x, that also means it's my top fingers. So the top of my numerator has to have 2 fingers. So that would be 1, 2, so I'm going to fold in this finger. Now, what angle does that finger represent? So this is 0, pi over 6, pi over 4.
Okay.
So I know that this is pi over 4. Because square root of 2 over 2 was positive, will pi over 4 work?
Yes.
Cosine's the easy one because all you have to do is make it negative. So both positive and negative, pi over 4 plus 2 pi n. Try F for homework. Or right now. Tucson, Kirkland says he needs you during tutorials.
I have a question.
Yes, ma'am.
So why wouldn't it be 3 pi over 4?